Hello again, we're back. I'm going to give you a very brief introduction into the Pythagorean theorem. Actually, talking about the Pythagorean theorem could take days upon days, maybe even weeks if you really wanted to extend it, in terms of theory, in terms of application. This is more of an algebra tutorial. If I do a geometry one or a trig, I'll talk about the Pythagorean theorem again. But for right now, it's just a very brief introduction. And you see a little bit of it in algebra, so that's why you do it. You just do a little bit of it. So the Pythagorean theorem is a squared plus b squared equals c squared. Basically what that means is this. It only works on a right triangle, only a right triangle, no other types of triangles. And if you have two sides of a triangle, those two sides squared, when you add them, well, you square them and then you add them up respectively, is going to equal the third side squared. And that's called a Pythagorean triple. Now there's many Pythagorean triples. The easiest one that you can use is 3, 4, 5. And if you want a little bit of proof into that, visual proof that is, then you can do that. You can also incorporate this with the distance formula, which we'll be doing very shortly thereafter, because they're actually included in the topic of radicals in general. So I've got this triangle and I want to kind of prove that a squared plus b squared equals c squared. Now, when it comes to doing a type of problem, a and b don't matter. You can interchange these two sides. But the hypotenuse, the side opposite this right triangle, the largest side is always the c squared on a right triangle. If it's not a right triangle, don't use the Pythagorean theorem because it's just a waste of time. And actually when you get into trig, that's where the law of sines and cosines comes in, which is really quite cool. So anyways, I've got this 3 by 3 square, 1, 2, 3, 1, 2, 3. 3 units across, 3 units down. And if I were to partition it, which is an applicable example of area, here's what would happen. If I count the number of squares, 9 squares. I'll do that for the 4 as well. Now I'm assuming that all the squares are good and I drew this with a ruler, which I clearly didn't, but use your imagination here. You can do it with a ruler if you really want to. Here I've got 16 squares. Here I've got 9 squares, or a total of 9 for my area. Here I'm going to write a 5 by 5 square because this one is 5. (25 squares). 9 squares plus 16 squares equals 25 squares. Well, that's fascinating and all. It's okay, but let me give you a type of problem. Useful type of problem. And of course you can make these problems more difficult. You can use this on any type of problem you want that has a 90-degree angle, or any type of situation where you have a 90-degree angle, which is why you're going to see it more in geometry and more in trig. Not as much in algebra, although it is required now. It was always required, actually. So anyways, back to what I was going to say. So I'll tell you a story about Pythagoras too if you want to hear it. You can otherwise just stop the tape early if you really, or video really early if you don't want to. So let's suppose you want to go to the store from your house. So here's your house, and here's a store, and you're going to cut through. You're going to go through the streets. So you're going to go this way, then you're going to cut to this road. So let's just say this way is 3 miles. And this is 4 miles. Now, it works as a Pythagorean triple, but if it were anything incorporated with a right angle, it would work. If it does not make a perfect 90-degree angle, then it wouldn't work. That seems like speculation, but you're just going to have to trust me there. And just figure out if something's perfect. I want to use 3, 4, and 5 because it's just very convenient. So I go 3 miles this way and I go 4 miles this way. All it's basically saying is if I create a right angle, and then let's say, instead of going from the store back to this road, back to my house, I want to cut through because I want to save as much time as possible. Well, it's more than 3, it's more than 4, but it's less than 3 and 4 combined. And how do you find that? You use the Pythagorean theorem. Everyone here. A squared plus b squared equals c squared. Now c is always the biggest one, and you don't know that. But I do know that a could either be 3 or 4, but we'll just go 3 because that's my first distance. So it's 3 squared plus 4 squared equals c squared. 3 squared is 9, plus 4 squared is 16, equals c squared. 9 plus 16 is 25, equals c squared. If you want to figure out c, take the square root of both sides. Now when you're taking the square root and you're trying to find distance, it's always the positive distance. Yes, I suppose you could say, well, isn't it plus or minus? But not when we're working with the concept of distance. So square root of 25 is, is 5. So if you wanted to take the shortcut, it'd be 5 miles instead of going 4 miles back this way and 3 miles this way. Although I don't know many people that walk to the store anymore in that regard. Now the Pythagorean theorem itself was not actually discovered by Pythagoras, but rather by his disciples. And I usually use the minute in my own classroom to discuss that to my own students. That, you know, if you want to be really good students of mine, disciples, what you can do is you can come up with mathematical theorems and prove them, and then name them after me. And usually that just causes a roar of protest, because they say, if I ever figure out a theorem on my own, I'm never going to give you credit, I'm only going to give myself. And I say, well, you know, don't you want to remember one of your teachers? And their usual response is no. I think they're just being funny, but at the same time maybe they're being very serious. Who can never tell? So that's a brief introduction into the Pythagorean theorem, pardon me. And we're going to talk about midpoint and distance afterwards, which is really cool and very applicable. But for right now, have a good day.